Now, example number 2 says, a computer randomly generates 4-digit passwords. Whenever I see problems like this, even though I don't even know what they're going to ask me yet, I know that I've got a 4-digit password, right? Okay. Now it says each digit can be used more than once. You know what that means? That means that the second event isn't dependent on the first one. Because if they use a 1, they throw it right back in and they can use it again. Right? If they couldn't use it again, that would be different. Okay? But it says that each digit can be used more than once. So I could have 2, 2, 2, and 2. Right? It says, what is the probability that the first 2 digits are 1? Well, let me ask you this, Teddy. What's the probability that just the first digit is 1?
1 out of 4. No, 1 out of 10.
1 out of 10. There are 10 digits, right? 0 through 9?
Yeah.
And one of them is a 1. So there's a 1 in 10 chance that I'm going to get a 1 on the first one. Now, what's the probability that I'm going to get a 1 on the second one? Fritz?
1 out of 10.
1 out of 10, because I can use it again, right? So that's 1 out of 10.
So basically, for each...
Hang on 1 second. I'm going to come right back to you. So what are the chances that both of those things happen, Alex?
That's 1 out of 20.
No. 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 Justin?
2 out of 20?
No. No. Teddy?
1 out of 100.
Exactly.
Oh, dang it.
1 out of 100. That's the probability that both of those things are going to happen. Fritz, what were you going to say?
Well, so basically, for every single independent event, it's just like it doesn't get lower.
It doesn't get lower. Now, here's what Fritz is asking. What if I couldn't use numbers twice? Okay? What if I can't use numbers twice? What is the probability that I'm going to get a 1 and then a 3? A 1 and then a 3. Okay? Well, hey, let me ask you this. What's the probability that I'm going to get a 1 and then a 1? Cole?
1 out of 9.
No. He didn't listen to my trick question. If I can't use numbers over and over again, what's the probability that I'm going to get a 1 and then a 1? Cole? 0, right? Because I can't use them again. But what's the probability that I'll get a 1 and then a 3? Alex?
1 out of 10.
No. What's the probability that the next one will be a 3, Albert?
1 out of 90.
Well, the next one being a 3 is just 1 out of 9. But the chances of getting a 1 and then a 3 is 1 out of 90. Okay? Because if I can use a 1 only once, then then I don't have that 1 to use for the next one. Zachary?
This kind of reminds me of a tree. So there's, like, say 10 trees.
Yep.
Each has 10 branches, which has 10 twigs.
Right.
Which each twig has 10 leaves.
10 leaves, right. But what if I have no, I like it. I like the tree diagram. Right? There are 10 times 10 times 10 times 10 possible combinations if you can use them over and over again.
And the trick is to do it sometime before fall.
Good job, guys. Let's look at the next example.